Well, the next type of problem that we will consider are where the forces, or where your consideration has to move from one joint to the next joint. So let's look at this picture. We have a traffic light here, which is obviously pulling down and causing some tension in those two cables. We have another traffic light, and it's causing some tension in those two cables. You can see that this one is horizontal in this point. The traffic lights have different weights, and we're looking for the tensions in the weights and that angle theta. So let's see if we can figure that out. What I'm going to recognize is that there are two, I'm going to call them points of consideration or joints, B and C. And what we'll want to do is draw free body diagrams of both of those joints and try to recognize something. First of all, you know that BC is pulling away from the joint there, and CB is pulling away from the joint there, and you know that BC from this perspective or CB from this perspective have to be equal to each other because they are the same cable. Alright, so let's draw the free body diagrams and see what we can find. I'm going to draw a free body diagram of point B. So I'm going to say that BC is going this way. I have a traffic light, and that's going to be 10 kilograms times 9.81 kilogram meters per second squared. That's the 9.81 meters per second squared, which is the gravity of in the metric system. And then we have AB going up like that. AB. Let's put the components of AB here. So I'm going to put it over here. I'm going to say that there's going to be an AB. And this will be the cosine of 15 and AB sine of 15 going up. Again, this would be the y direction. This is the x direction. Let's go ahead and draw the free body diagram of point C now. Point C has the weight coming down from there of that traffic light, so that is going to be 15 kilograms times 9.81. It's got a force going up here. I'll call that CD, and then it has BC or CB, either way you want to refer to it, going that way. Again, this is going to be the x direction and the y direction. So let's put our component forces in here. I'll say that this is going to be CD cosine of theta, where that's an unknown, and then we have CD sine of theta going that way. Alright, once I have the free body diagrams drawn, then move to the equations of equilibrium. So I'm just going to move this up here. We don't really need that picture anymore, and I'm just going to show you the solutions, okay? Or show you how to do the solutions properly. So let's go back to the left picture now. The sum of the forces in the x have to be equal to 0. So I'm going to say that is minus AB cosine 15 plus BC is equal to 0. Can't solve for either one of those quite yet. So let's do the sum of the forces in the y. Minus 10 times 9.81 plus AB sine 15. This has one equation. This is one equation with one unknown, so I can solve for AB right there. Now I know the tension in AB. I can plug that back into this equation and solve for BC. Once I have AB and BC, I can move over to here. Again, I know that BC has the same force in this picture as it does in that picture. They're both in tension. So I can sum the forces in the x here. So I got minus BC plus CD cosine 15, or CD cosine theta, which is an unknown. And I can't solve for either CD or theta at this point, but let's do it in the y direction, see what I can find. Sum of the forces in the y, I got minus 15 times 9.81 plus CD sine theta, and I got here I got two equations and two unknowns. I don't know CD and I don't know theta. So how do I solve that? Well, as I did perhaps in the one of the sections before, I like to divide equations. I think that is a handy thing to do. So I'm going to divide these two equations and see what I get. I'm going to bring those two things over to the other side of the equation, so I hope that you can follow this. I'm going to say that CD sine theta over CD. Well, actually, let me set this up a little bit different. I'm going to say that CD equals 336 and CD cosine theta. Oh, I'm sorry, I did this wrong. Come on, eraser. CD sine theta equals 15 times 9.81, and CD cosine theta is equal to 336. Okay, now I can divide these two equations. I'm going to say that divide by that, and I'm going to get rid of that equal sign and put an equal sign there. And that's how you do the dividing of the equations. When you do that, then CD ends up canceling because, CD ends up canceling because it's in both the numerator and the denominator. Sine over cosine is equal to tangent theta. Take the inverse tan, you do that, divide that and take the inverse tan, and you can solve this for theta is equal to 21.9 degrees. And that's the first question, or first answer to the question anyway. Once you find out 29.9 degrees, you can plug it into that equation or that equation and then find out what CD is. So I solve CD is equal to 394.5 newtons. Okay, so here's one I'd like you to do on your own. Go ahead and pause the video now for a few minutes while you approach this problem. But what we're looking for is the tension in each of those chords. And some of them are going to be quite easy and some of them are going to take a little bit of time. Recognize that the tension in AB or BA is going to be the same regardless of how you approach the problem. Alright, so pause the video while you work on this and I will show you the solution in a few minutes. Okay, here is the solution to 326. First of all, let's draw the free body diagrams of the points in question. So there's a point there, point A and point B. Again, these are knots. So if I look at point A, let's do point, well, I guess I did point B first. That's fine. So again, there's going to be a BC pointing that way, BD going that way, BA going that way. So here's the point, BC, BD, and this is going to be the 4/5 component, the 3/5 component of BD, and this is going to be 60 degrees here, which means that this is going to be 60 degrees here. So I use this as the cosine component of BA, BA the sine component. All right, let's move down to point A. So point A looks like this. AE is going to go straight that way. AB goes this way. This is going to be 60 degrees, so this will be the cosine component, the sine component. Pulling down will be the weight of 30 times 9.81, and then just work on the forces. So let's move on down here. Let's do the first free body diagram for point B. Some of the forces in the Y, some of the forces in the X, then point A. Actually, which way do you get started? And this is kind of a common question, and is start where you know something. So in this question, where do we know something? We only know something about that weight. In other words, we know the tension in this chord and that sort of thing. So it's appropriate to start your calculations. You can draw the free body diagrams in any way you want, or in any order that you want, but the way you get started is to start here. So let's move down here, and I'm going to sum the forces in the X and the Y for point A. So some of the forces in the X, whoops, let's go back to this. Some of the forces in the X, some of the forces in the Y, and you can, if you do some of the forces in the Y, you can find out with one equation the tension in AB. Then then plug that into the X equation, then you can find tension in AE. From there, you can move to this equation or this picture. Let's move back down here now. So some of the forces in the Y, once I know this force, I can find this force. And then once I know both of those forces, I can find that force. So it is a bit of a process. There is some methodology to that, and I hope that this makes sense and works for you.